For my final project, I did a project in constructive geometry where I attempted to make a baby version of Minecraft. So if you're not familiar with Minecraft, the way it works is that you have a terrain basically, and the terrain is full of these cubes. And if I select a side of the cube and I click that side, I should be able to add cubes. And in addition, you have different blocks, so it'd be pretty boring if all we had was bricks. So I added different blocks, like you can press the 1, 2, 3, or 4 keys to select different block textures. So I can click the 2 key and now I'll render a grass block. And if I click the 3 key, I can render another one of the textures. I think this is a specular. And if I press the 4 key, then I get this block. So I can do this selecting any side of any cube. If I press the 1 key, of course, I go back to the brick. So the way I operate this is using the WASD keys to move around and the arrow keys to pan the camera. And you'll notice that if I pan the camera, then the moving direction changes with the camera. So if I go like this and then I hit the forward button, W, then I move in the direction of the camera, as opposed to having a fixed view movement. The hardest part about this was basically a 3D selection. So the original way of doing this was basically I had a root cube, aka the first cube that's rendered, and the neighbors of the cube branched off of that parent cube. But the problem with this was basically if I select a side of the cube, the naive selection would basically be get the mouse coordinates and get all of the transformed sides and see which sides have the mouse coordinates in bounds. The problem is though, say I have my mouse over here, then this square technically has that mouse coordinate in bounds. This square has that mouse coordinate in bounds, and also if you look at it, squares like over here would also have that mouse coordinate in bounds. So how do we find the side that's closest to the person without doing some kind of crazy tree traversal and getting computationally expensive? To fix this, what I did was I had the scene graph, which was the parent cube and all of its neighbors, but I also implemented a separate parallel object manager class similar to Lab 9. So using the object manager class, we could basically assign pointers to get all of the z-values of all of the closest sides. So for every cube, get the side that is the closest to the pointer. So for example, even on one cube, different sides could overlap. So like the front side of this cube and also the back side of this cube would have this mouse coordinates in bounds when transformed. So we only get the side that has the minimal z-value, and we push it to a vector from the object manager class. And then within the object manager class, we then get all of these z-values of all of the sides, and then get the minimal z-value, aka the one that's the furthest or the closest to the viewer, and only select that one side. That way when I click here, there's only one cube added, and it's the most appropriate place to add it to. So that's my project. A couple notes: if you find that a side isn't being selected, just try panning the camera, and that should do the trick. I hope you enjoy reading my code.